Hi, I'm Nick Weaver, and I'm here to talk about cryptocurrencies. My work in this area is largely sponsored by the National Science Foundation, but of course, all opinions are my own. This is also not investment advice, but then again, my advice to anyone who says you should invest in cryptocurrencies, you should just kick them. I've been researching and writing about this space academically as well as for general interest publications for over 5 years now. Now, most others who followed this space for this long are true believers, because basically everybody else who looked at this space 5 years ago went, oh, this is male bovine excrement, moved on, because they didn't have a monetization model. I do. I can watch it, mine the comedy gold, and turn it into papers and essays. Also, to be honest, this is a little bit of dancing on the graves, so yay. So first of all, what is a cryptocurrency? The goal of a cryptocurrency is to create irreversible electronic cash with no central authorities, so that no one else can block or reverse a transfer. So if Alice wants to pay Bob 100 quatlus for the winning bet on the green thrall, she writes a check, cryptographically signs it, and hands it to Bob. But is the check any good? Well, there's a public ledger of all previously canceled checks. So you just look in the ledger, see if Alice has a positive balance, and if so, the check's good. The check is added to the global ledger, and now Bob is up 100 quatlus, Alice is down 100 quatlus. So how do we secure this ledger? Enter the blockchain. A blockchain is simply a hash chain so that each bundle of canceled checks includes the cryptographic hash of the previous bundle. Since cryptographic hashes are effectively long, unique, random numbers that you effectively uniquely identify the identifier, or identify the document, if we know the most recent block is valid, and it has the hash of the previous block, we can now know that the previous block is valid. That has the hash of the previous one, and go on and so forth. This creates an append-only data structure where you can only add data to the ledger, you can't remove it. So how do we add new entries? Well, a whole bunch of participants take all the bundles of checks together. These are the miners. They gather up the new checks, ensure they're valid, add a pay to myself value, and include a pointer to the previous block, and staple it together with a cryptographic hash. But in order to ensure somebody can't play games, the cryptographic hash of the bundle has to be below a certain magic number, the difficulty factor. If it isn't, you just tweak the pay me, because we also know that cryptographic hashes look random. So you change a bit in your pay me check, and now the hash is totally different. So this creates a proof of work system, because if you present a hash that starts with enough leading zeros, you had to expect to do so many hashes to find that. So everybody keeps at it until one person gets lucky. He broadcasts or she broadcasts the block, and now everybody starts over again with the next block. Now, when you hear advocates talk about this, you hear about a blockchain revolution. And in that, they conflate two totally different things. The first is the public or permissionless blockchains, like we just showed. These are supposed to be decentralized and trustless. What that means and why they aren't, I'll explain later. And which are really only used for cryptocurrencies. And then you have the permissioned or private chains, which are simply an append-only data structure signed by one or a few entities. And yes, such structures are incredibly useful. They're also 20 years old, and we call them hash chains. But you stick that blockchain bird on something as a management consultant, and now idiots will throw money at you. Of course, real hash chain projects, like certificate transparency efforts, don't bother calling themselves blockchains. So in this end, there will be no blockchain revolution, because anything that can benefit from an append-only ledger should already be in your Git archive or something else like that. And so for all who say blockchain will solve X, this actually does solve one important problem. You now know they know nothing about X. So what is Bitcoin? Bitcoin is just simply the first incarnation. A Bitcoin address is simply a hash of a public key. A Bitcoin wallet is something that holds the private keys. And to spend Bitcoin, you simply create a check, cryptographically sign it with the corresponding private key, and send it off. And this is an example of one. This was when I gave a token sum to a convicted drug dealer. And once the miners include it, it's now official and irreversible. Unfortunately, there's a problem. This design doesn't actually work for currency. The first thing a currency needs to do is it needs to actually be useful for transactions. And in all this, the volatile cryptocurrencies all fall flat. By design, they're supposed to have no central authorities, no reversibility. But that means they're fundamentally incompatible with modern finance. The modern financial system relies on reversibility, an undo button, in order to mitigate fraud. Since Bitcoin by design doesn't have this, all the cryptocurrencies can't actually interface with the rest of the financial system unless you go through some step to counter the irreversibility. Which means if you want to buy cryptocurrency, you either need to bring cash to stick into a cryptocurrency ATM, you have a deal with an exchange that is implicitly giving you credit, or you transfer your money to the exchange or the seller and let it sit for a while. If you don't follow one of these three rules, you can end up like this guy who sold $75,000 worth of Bitcoin to somebody who paid with PayPal and then found out that it was a stolen credit card. Fortunately, I think he could afford the loss. But it's even worse. They're harder to hold on to. You clearly can't store your cryptocurrencies at a third party with a third party because they are hacked with disturbing regularity, and there's no government-backed insurance, so when you get hacked, or when the exchange gets hacked, sorry for your loss. But you can't store them on your own internet-connected computer either, because the best intrusion detection system probably for a host is an unsecured Bitcoin wallet. When it gets stolen, you know you got compromised. This is not a joke. We actually detected a compromise this way when a graduate student's account containing our Tripwire account got broken into. So this is supposed to be the internet of money, yet you can't store it on an internet-connected computer. But, OK, so let's use a secure device, like a dedicated phone. Because let's face it, iPhones are probably the most secure device you can buy, or a Google Pixel. You have to trust the code that's running on it, which may be compromised when even something so minor as an NPM library that the code uses is compromised. So they're hard to buy, they're harder to hold, and they're even harder to spend. So firstly, in the past 5 years, the fraction of merchants accepting cryptocurrency has basically stayed the same. The fraction is pretty much zero because none of them, modulo one or two exceptions, is actually taking cryptocurrency. Instead, they're using a service like BitPay that allows them to price in dollars. BitPay says what it will be in cryptocurrency. The other party transfers the cryptocurrency. BitPay immediately churns it into dollars because otherwise the merchant is looking at this price going up and down and doesn't want it. Now, this means that the buyer, in order for things to match up, had to have done the same thing, had to have converted dollars to cryptocurrency and then spend it, unless the buyer loves this earthquake-level stability. This means that any real-world cryptocurrency transaction involves two currency conversion steps, which makes it more expensive than Visa, PayPal, Venmo, M-Pesa, Zelle, Western Union, etc. The only exception is if you believed in the cryptocurrency and were holding it for a while. Now, these cryptocurrencies have a problem. They're designed to be deflationary. That is, your money is worth more tomorrow than today, basically recapitulating the gold standard. For all of those who slept through Econ 1 It was a disaster because the reason is, in a deflationary currency, rule number 1 is never spend your currency. Lest that 10,000 Bitcoin pizza fill your stomach with a Breaking Bad pile of regret a few years down the road. So what good are they? They're good for one thing, that is censorship resistance. There is no central authority, supposedly, that will block or reverse transactions. The cryptocurrencies are the only electronic payment system with this property. So they're good for buying drugs. They're good for extorting people. Pay us Bitcoin or bombs will go off, your data will never be seen again, we'll release your porn. You name it, they extort it. Now, if you believe that censorship is bad, you only have the cryptocurrencies. And there are 2 cases that advocates of cryptocurrency will point to. So if you wanted to send money to an alleged rapist hiding in the Ecuadorian embassy, you had to use cryptocurrency for a while because they were cut off from Visa and MasterCard, until, of course, they arranged for a US nonprofit to launder contributions. And similarly, Backpage was a competitor to Craigslist. And if you wanted to pay for your prostitute ads, you had to use cryptocurrency or send them a check because they were, oh, actually, wait, that was also a criminal enterprise. So that's the cryptocurrencies. But these public blockchains based on proof of work are also inefficient or insecure. So the whole point of proof of work is not about securing consensus, that is, a global view of the system. It's really about blocking Sybils, that is, somebody from spinning up a gazillion nodes and getting a gazillion votes. So it works under the assumption that an attacker won't burn more money than the network already is, which is fine security if you're willing to burn Joker stacks of money. And right now, Bitcoin is secured by literally burning $6 million a day under the assumption that an attacker won't bother. Of course, if you're willing to articulate the trust, you could compute Bitcoin's 3 transactions per second on a couple of Raspberry Pis scattered around the world. That uses about as much power as a light bulb rather than as much power as Ireland. Now, the problem is this is all economic protection. The assumption is if the attacker can spend Y dollars greater than X in that hour, the attacker wins. And so as a consequence, the proof of work cryptocurrencies that aren't literally burning hundreds of thousands of dollars an hour are being attacked by attackers, because as long as you can make more money in that hour than it costs to run for just that hour, it's good for the attacker. Oh, and suppose you want to do one of these attacks. There's a service that will allow you to buy the compute to do it. And finally, we have decentralization, the idea that the system is distributed across a huge number of computers, and in that process, you only need to trust the system in aggregate, not individual players, and that there are no central authorities in these supposedly trustless systems. But overall, the benefits of decentralization are stated without backing. Except for censorship resistance, there's nothing that these decentralized systems do better than systems based on trusted parties, federated agreements, or other conventional solutions where you understand who they are. But they aren't even decentralized anyway. We'll see in a sec how the developers are central authorities, but so are the mining pools. So they, what decentralization? There's been only one innovation, smart contracts. What are they? The idea, let's take things written in a formal language, we call it legalese, it kind of looks like English, rewrite it in a language that makes JavaScript seem sane, and ditch the exception handling mechanism, so that if something goes wrong, oh well. So if you can steal from a smart contract by telling it to give you the money, is it really theft? Well, fortunately for smart contracts, they're actually a simpler idea. They're buggy finance bots and million-dollar bug bounties. Now, our modern financial system runs on programs that act on money. The difference is these are public, so anybody can interact with them. And the results have been amusingly spectacular. So we had the DAO, the Decentralized Autonomous Organization, a distributed mutual fund that collected 7% of all Ethereum before somebody figured out how to steal the money. And then the Ethereum developers go, you know that whole code is law business and no central authorities? Yeah, we lied about that. We're changing the code, undoing the law, because you stole our money, damn it. Then there was the Parity multi-signature wallet designed to keep your money safe by multi-party checks. Unfortunately, there was a bug where somebody could come up to it, say, hey, give me your money, and it did. That didn't cause more than a few $1 million worth of theft because a good guy came along and did that to everybody and then gave the money back. Until a second bug came along that managed to basically go, hey, master library that all wallets belong to, you belong to me, go kill yourself. And now over $100 million was locked up, never to be seen again, unless we once again forget that whole no central authorities business. The bonus, the lead guy behind this company is the guy who invented the smart contract programming language. And finally, we have the lovely thing, the fear of missing out, 3D, a fair Ponzi scheme as a smart contract with a bonus. The last to contribute gets a huge payout. So somebody went and did a attack where they paid into the smart contract, then spammed the blockchain so no transactions went through, and took all the money for themselves. Everything else is speed running 500 years of economic failure. You have the gold bugisms. You have exchanges that are so blatantly manipulated you can draw Bart Simpson. That is actually a Bitcoin price chart from a month ago. We have Ponzi schemes. We have stock touts. We have celebrities in our case. Anybody for alchemy on the blockchain. And it isn't a proper speed run without recapitulating tulip mania. Somebody bought this fine specimen of a cat, hoping somebody else would pay for more. So what to do about it, beyond just pointing and laughing? First of all, these targets are ripe for attack. Let's just take one example. Bitcoin beget Litecoin, beget Lucky Coin, beget Dogecoin. Dogecoin is another peer-to-peer cryptocurrency that's a fork of a fork with code starting at Bitcoin. Why does this matter? You know how I said you aren't supposed to store your cryptocurrency on an internet-connected computer? People do. So what if somebody targets Dogecoin? It's a top 25 cryptocurrency. There's a lot of it around. No updates for 2 years. Unpatched C++. Oh, great. So if you live in Pyongyang or Sochi or some other place where US law enforcement basically can't reach you, you write a cryptocurrency stealing worm that spreads through Dogecoin, steals all the other cryptocurrencies that it can find, and gives it to you. The amount of time it would take to propagate is probably about 3 seconds, maybe 4, something in that. Then we have just actually enforcing the laws. The amount of criminality in the space is simply off the hook. It is what you call a target-rich environment. Now, the US government, for a long time, avoided getting involved. I think for fear of being accused of stifling innovation. But now that things are collapsing, there's no innovation to stifle, so actually enforce the laws. The IRS has started doing this, subpoenaing cryptocurrency exchanges. The SEC now has a standard template for every ICO fraud. This Commodities Future Trading Commission is finally going, hey, these exchanges are bad. And finally, these systems are vulnerable to technical attacks. So back in 2015, somebody, for the heck of it, said, I don't want Bitcoin to run by doing spam transactions. And in 2017, the Bitcoin network collapsed on its own, charging $30 a transaction in a death spiral situation. Now, attackers can exploit this. When you're below the death spiral point, spam away. When you're above the death spiral point, just sit back and laugh. Now, the normal spam game is you want your spam to get through filters. This spam game, you want the filters. Because what you want to do is train your spam so that normal filters, or so that filters block normal transactions. How well would a cryptocurrency work if, say, 1 to 3% of the transactions just died due to spam filters? Ethereum in particular seems a delicious target. The Ethereum blockchain is over 2 terabytes. The working set is measured in the tens to hundreds of gigabytes. As an attacker, wouldn't it be fun to add a 0 or 2 to those numbers? So in conclusion, it's a dismal space. Private and permission blockchains are an old idea, a good idea, just with a new buzzword on it, and a buzzword that screams they're ignorant. The public blockchains are grossly inefficient. The cryptocurrencies don't work for buying anything against drugs and ransoms and stuff like that. Smart contracts are an unmitigated disaster, unless you like comedy gold. And the field is just recapitulating 500 years of failures. So in the end, the only winning move is not to play, unless you like playing with flamethrowers.